Hello everybody and welcome to vBrownbag. My name is Andrew Sullivan and I'm going to be giving a presentation on Git and GitHub fundamentals. So my role here at NetApp is as a technical marketing engineer, and among other things, one of my focuses is containers and applications that are leveraging containers for their deployment model. And this means a number of different things, right? Applications, particularly cloud-native applications, particularly those that are leveraging containers for deployment, are often homegrown applications, which means that we're leveraging things like Git in order to provide that source control, in order to provide revision control over our different resources. But Git is useful for a number of other things as well. Whether I'm a system administrator, whether I'm an automator, whether I'm a true developer, I can leverage Git in order to manage and maintain configuration information for, well, my environment. For example, if I'm a system administrator, maybe I want to document what my configuration looks like today and check that into source control. I can then go through and change it. The next time I create a new volume, the next time I deploy a new virtual machine or provision an IP address, I check it in again. I use source control in order to maintain and be able to revert back and look at how my configuration, how my system looked at any given point in time. So this is why Git and really source control in general are important tools, regardless of your role at your organization, regardless of what your day-to-day duties might actually be. So let's get started. And the first thing that we want to look at is, well, what is Git? Git is something that we talk about frequently. We hear it mentioned as repositories, but ultimately it is a command that is used to maintain control over text files. Right? Text files in this instance being code, it could be configuration, it could be documentation, it could be any number of other things. And infrequently, we also use Git for doing things like binary object management. So sometimes we have a picture, right, or a Word document, or any number of other things that may be binary that we want to have in the same repository with our source files. So Git uses files, or manages files rather, using repositories. And a repository can be created in a number of different places. It can be created locally on my laptop or my desktop, where I can now manage those files without having to push them out anywhere else. I could create it on a remote system so that I can connect and be able to do it there. And remote here can reference a number of different things. It could be simply a server that I connect to with SSH or HTTP. It could be a third-party product through something like GitLab, or more frequently, we see GitHub being used. So GitHub is a public repository, a public website for hosting repositories. So I'm using the standard Git, the standard set of commands on my laptop or my desktop in order to interact with and update and maintain my code files. And then I push that up to GitHub, where it is now publicly available or generally available. However, you can have private repositories on GitHub if you so choose. So that way I can have a team of people be able to manage and collaborate off of a single project. That's the real goal of shared repositories. A local repository only available to me, a shared repository available to my entire team, and we work together. Git works together with me in order to ensure that I am not going to stomp all over somebody else's changes. So let's look at the basic commands inside of Git. And I think it's important to remember that Git is massively complex, but relatively simple to get started with. I can do basic revision control of any files with only a handful of commands. So let's look at some of the concepts inside of Git. So the first thing that we want to understand is, what is Git clone? You see, Git clone is the fundamental process of, well, creating a local copy of an existing repository. So all I need to do if I have a set of code or documentation or whatever that happens to be, and I want to bring it locally, is git clone and then a link to that repository. It could be HTTP, it could be HTTPS, it could be SSH. All of them will work, assuming my credentials are in order. Now, if we look at the graphic that is on the right side of the slide here, you notice that we have a remote master. Master typically refers to the main code line, right? The main set of code that is being used, and it is the current production code line as well. When we create a clone, we are literally creating a copy of that, including all of the history for our repository on my local machine, so that any changes I make are not automatically done on that remote repository. Again, for work group environments, this is tremendously helpful. We can all simultaneously work off of the same code set without interfering with each other. Also in the graphic here, down at the bottom, we have an example of what this looks like using NetApp's Docker Volume plugin. So we can see very simply it is one command with two options in order to go out, clone that repository, have all of that code base available to me on my workstation. So the next command that we want to look at is the branch. You see, a branch essentially creates a subset, or it forks off, well, fork is a bad word here. Branch creates an isolated set of changes. So if I am implementing a new feature or a bug fix, and I want to encapsulate all of the changes that I'm making into one commit back up to the mainline, I want to use a branch. This means that, again, I am not affecting what other people are doing inside of that work environment, whether I'm working off of a remote repository or off of a local repository leveraging my branch. Now, the reason I said that fork is a bad word a minute ago is because a fork actually represents something different inside of Git. You see, a fork is when we do a clone and at the same time create a branch off of that. So that way I don't have to go in and I don't have to do all of that. Typically we associate forks with doing things like creating a bug fix. Right? An issue is filed, I want to go in and fix that issue, so let me create a fork. I now have a local copy with a branch that I can begin to work off of, fix that bug, and then push it back up. And we'll talk about that process in just a moment. So a couple of interesting things to note here. Again, the master branch is special. It is canonical. It is the reference, it is the production code set that exists today. So we want to be very careful as we go forward and make sure that we aren't just making modifications willy-nilly. And this is where, again, something like Git for the source revision control is important. So at this point, I have now gone through the process. I created my branch. I did all of my code modifications. Right? I'm ready to say I am done with this. Right? I think it's going to work. So the way that we do that is with a commit. And what that does is it takes all of the changes that we've done inside of our code base from what the reference is, maybe the master or our local clone or our branch, and it creates a checkpoint. So I can update one file, I can maybe fix a bug, I create a commit that says bug number 17 fixed. Maybe I go and fix another bug, bug number 23 fixed. The commit creates that point in time reference, something similar to a snapshot, because I can also revert back to that commit if something happens. If I accidentally modify something that, well, I really didn't want to modify, or I created more technical debt through poor coding implementation. Now, committing is really, really easy. There's two steps to it. The first thing that I need to do is add the files that have been changed into the commit set. So git add along with the file set. I can specify these as a whole, star. I can specify individual files. Once I've added the files to the change set, I simply do a git commit along with a message. A very short description of what I have actually changed so that others are able to look at it and quickly figure out what's happening. So committing is super important. It is fundamental to what's happening within our source revision control, because that is how we are able to create those point-in-time snapshots, those point-in-time references of what the code base looks like, and I can go back and I can look and see not just what did the code look like, but who modified it, and when did they modify it at any point in time. So now that we've committed our code changes, we want to go ahead and do a merge. This is where we take all of our change sets and we push it back into the main code line using the merge command. Now, merge does a couple of interesting things for us. First, it does conflict resolution. So if I have a file that was modified by both myself as well as perhaps one of my teammates, we were just working on different functions or different options inside of there, well, it's going to look at that and it's going to say, well, this file was modified. What should we keep? Should we literally merge the two files together? Should we keep one change set and discard the other? And it will ask you these questions when you actually do that merge operation. So merging is important. We want to do it distinctly, we want to do it deliberately, and we need to actually think through what's happening here, especially in a workgroup environment where there may be multiple modifications happening simultaneously. If we look at our graphic here at the bottom, you can see that our very simple merge that happened here was all we did was make a single modification to a documentation file, and push it up and make it available. So the last thing that we need to do is a push. Now, a push is what actually takes any local modifications after we have done our conflict resolution or any of those things and pushes them up to the remote location. Now, oftentimes when we're working on something like an open source project or even a larger development project, myself or my team may have created a new feature or fixed a new bug or whatever that operation happens to be, but somebody else owns the mainline code base. So what we do when we create a push is we also want to create a merge request, or sometimes called a pull request. What this does is it notifies the owner of the mainline that, hey, I have some changes that I have submitted that I believe should be included into the main code line. Please review them, please accept them or reject them depending on what needs to happen there. So the push operation is super important for taking all of those changes that I have made locally and putting them up onto that remote repository, ensuring that they are now available for the rest of the worker. So we covered the fundamental processes, the fundamental commands that we have inside of Git for doing that basic level of source control revision. From a workflow perspective, they more or less follow the order that we just used. When I want to actually do a modification, whether it's to documentation or code, right, I need to clone a repository. I need to bring that code base local or that documentation base local. After that, if it's something easy, maybe I don't want to create a branch. However, it is generally recommended that you always create a branch so you can isolate change sets. So we create a branch. One command, git, is one command in order to go through and do that. And then I can now function without having to worry about stepping on anybody else. We make our changes. We go through, we actually modify what's happening inside of our code base and ensure that it's going to happen, or it's going to fix whatever was broken. Once I'm satisfied that that's happened, I commit the change. I make it so that I have that point in time recovery, that point in time status inside of my code base, and then I push the changes up to the repository. At that point, if it is a shared repository, if it is not my code base, I submit my merge request in order to go through and have all of my code brought into whatever is happening up above. So ultimately, Git is a simple tool. It is a powerful tool. It is something that we should all be adopting, whether we are system administrators doing configuration management, configuration control, or whether we are truly developers who are going through and making modifications to massive code bases. I highly encourage you to check out the documentation at github.com if you're curious about more details on how Git works, as well as just using the internet as a whole. Git is an extremely common source revision control management tool, and it is an extremely powerful one as well. So there's very few things that we can't do with it. Thank you very much for your time, and I greatly appreciate it. Have a great day.